Donnie Weir. Thank you for taking the time to check out my project. For the past year and a half, the majority of my spare time has been spent building the large-scale 5-axis CNC router you see in the simulation behind me. My goal is to create an industrial-quality 5-axis CNC router that is attainable to hobbyists by making it modular and creating kits to be sold in various stages of completion. For the most part, the build is taking place in my home garage using roughly $10,000 from my savings and approximately a year's worth of labor, in addition to my full-time job as a maintenance planner for a Fortune 1000 company. The project is a little more than halfway complete, but I'm afraid I won't be able to complete it without your help. As you can see, last week I finally got the router to move under its own power. You can check out my website, wrigglerobotics.com, for more details on the build. Before I go any further, I'd like to tell you a little about myself. Ever since I was 5 years old, I wanted to be an inventor. I've always wanted to come up with the next big thing. Like many of us out there with Da Vinci-esque ambitions, I've always had great ideas, but never had the resources to bring them to fruition before someone else does. That's why this project is so important. This router will be a tool to bring my conceptions to life, as well as help others make their concepts a reality. You may be asking yourself, what is a CNC router? Well, it's a computer-controlled carving or shaping machine, much like a CNC mill. Unlike a 3D printer, which adds material to create an object, a CNC router removes material to create an object. Because it's computer controlled, it can create objects with extreme accuracy and repeatability. Today, 3-axis CNC routers are readily available to hobbyists and manufacturers, but 5-axis routers start at around $50,000 and can cost several $100,000. This router can be built in your garage for a fraction of that. 3-axis router travels on the X, Y, and Z directions of the Cartesian coordinate system. This makes them great for cutting things like signs, cabinet doors, and other objects designed to be cut on one plane from one direction. The problem is if you have overhangs, you need to drill holes on faces that aren't perpendicular to the Z-axis. You have to remove the object and set it up again perpendicular to the Z-axis. Because the 5-axis router has the additional C-axis and A-axis, the only places you can't cut are those that are so deep that the tool can't reach without a collision, or the area being used to hold or support the object being cut. Keeping the hobbyist in mind, I incorporated a telescoping Z-axis and a modular frame. This provides a maximum of 6 feet of vertical stroke, while allowing the router to fit under a lower roof than other routers of similar scale. Once it's complete, I'll be able to build subsequent routers in a week or two instead of the better part of a year. There are very few things you can't cut from foam, wood, and other soft metals using this router. I'm a car guy, so I chose to create this car in the simulation. Thanks again for watching my video, and please check out wrigglerobotics.com for more details